Hello everyone. Let me introduce myself. My name is Vikram Kumar Soni from Bokaro, Jharkhand, and I am currently working in Narayana Jamshedpur for 3 years. Before that, I was in Vidya Mandir classes, Panipat, for 1 year, and before that, I was in CSRR Super 30. And I have done my BTech and MTech from IIT ISM Dhanbad from 2012 to 2017, and I am taking chemistry classes in Narayana Jamshedpur. That's all from my side. Now we will start a new chapter, that is electrochemistry, and in that we will start a small topic, that is a galvanic cell. It is a very conceptual part and very important part. Now let's start it. So in this chapter, electrochemistry, what we deal with, we deal with the batteries. We deal with the batteries in every applications, like in the watches, in the cars, in the calculators, and everything we have batteries. So what is the battery? Battery is a device, is electrochemical cell that converts the chemical energy to electrical. And now in this chapter, we will deal with the conversion of chemical energy chemical energy to electrical energy and vice versa. This means if we have to convert the chemical energy to electrical energy and electrical energy to chemical energy. Actually, what do you mean by this chemical energy? Chemical energy means the energy which is in a stored form, like in the coal, petroleum, in the bonds of the chemical compounds. And what is the electrical energy? Electrical energy means the energy which is caused due to the flow of electrons or the charges. So, in this chapter, we will deal with these energies. So, our small topic is the galvanic cell. So galvanic cell is also known as voltaic cell. Voltaic cell, also known as Daniel cell. So what is this galvanic cell? So first of all, we will have the principle, then the construction, then the working of the galvanic cell. So the in galvanic cell, what we use a simple spontaneous chemical reaction, which is a stored form in a chemical energy, and that energy is converted into electrical energy. Means in galvanic cell, we are converting chemical energy to electrical energy we are converting chemical energy to electrical energy, and through a through spontaneous chemical reaction. So we are converting a chemical energy, which is a stored form of energy, which is stored in the chemical compounds, and where we have a spontaneous chemical reaction, which is converting it to the electrical energy. We are having electrical current from this cell. So what is in the Daniel cell? What is in the galvanic cell? Let's start for the construction and basic principle. So for the galvanic cell, the basic principle, when the basic principle is what? So when we dip a metal strip on a solution, suppose we have a solution and a metal strip is dipped, and the metal strip may be any metal or any even a gases. So the metal, suppose we are taking zinc, we are taking aluminum, iron, etc., and we are putting the metal in a solution. Suppose we are taking zinc sulfate for the zinc strip. So when a metal is dipped in a solution, then it undergo oxidation or reduction. So oxidation and reduction occur simultaneously, and after that we have a potential difference generated between the metal and the liquid solution. So due to this potential difference generated, there is a charge in the rods, and when the two strips having the opposite charges are connected by a wire, then the current will start to flow. And this current is known as electricity. And when we are connecting the wire with a voltage, a meter, voltmeter, or a bulb, then it will start to glow. Now, so this is the basic principle. Now, coming to the construction. Coming to the construction of the galvanic cell. So the basic construction of the galvanic cell is to take two beakers. Two small beakers are taken, and in the two beakers we have to dip two strip to the two rods to metal strip, and these strips are known as electrodes. So these strips are dipped in its solution only. Suppose if you have zinc, then the dip it in the zinc sulfate, and it is copper, zinc in the copper sulfate. So I have to take two. Suppose this is zinc and this is copper, and we have to take it zinc sulfate solution here, and we have to take copper sulfate solution here. And after dipping these two electrodes, connect these two electrodes with wire, and between the wires you can connect bulb or the voltmeter to measure the potential difference between the rods. Now the two beakers are connected by a small u-shaped glass tube, and that is called as salt bridge. So this is called as salt bridge. So we will discuss salt bridge later. So this is the basic construction, and when we are connecting the bulb here, the bulb will start to glow. So this is the basic construction. Now, how it is working? Now we have to discuss about the working of this cell. Let's discuss it. So now construction and working. So how a galvanic cell work? So this is called as oxidation half cell, and this is called as reduction half cell. So what happened in oxidation half cell is we are putting the rod in the solution, and this is called as anode. It's called as anode, and this is called as cathode. Now, what happens in the anode? Let's see what's happened in the anode. Anode means it's a electrode where oxidation occur. So in the oxidation half cell, we are dipping the anode, and this anode has oxidation in the reaction. So we have oxidation. So here we have oxidation occur. Now in oxidation reaction, what happens is the zinc will be converted to zinc plus 2, and it will lose electrons. So loss of electron is known as oxidation. So what is happening here? The zinc, suppose we have taking one zinc, and this zinc on oxidizing is converting to zinc plus 2. So this zinc plus 2 will be going out in the solution and leaving behind electrons. This will leave the two electrons. These electrons will be left in the rod itself. So we have surplus electrons in the rod. So this rod will become negatively charged because the zinc is after oxidation is coming out of the rod and leaving behind the surplus electrons. So the rod become negatively charged. So this will be acting as a source of electron. So this is acting as a source of electrons. So this means the anode will be negatively charged. So in the galvanic cell, anode is negatively charged. Now coming into the cathode. So cathode means what? Cathode is an electrode where reduction occur. Cathode is a electrode where reduction occur. So when we are looking into the copper, so copper cannot be reduced further because copper is a metal. So metal will be always a positively charged rod. So what will happen? This copper plus 2. copper plus 2 in the solution, copper plus 2 in the solution will extract the electron, from the copper atom present in the rod. So this copper plus 2 will take out the electron, and this copper plus 2 will be forming copper solid. So this copper solid will be depositing in the cathode. So we have the deposition of the copper metal in the copper rod. Now this copper plus 2 will take out the electrons, and what will happen? This the rod will become positive charge. Why it will become positive charge? Because the copper plus 2 is taking out the electrons from the atom present in the rod. So the copper rod, the cathode electrode will become deficiency, will have the deficiency of electron. So this will have electron deficiency. Now, so we have the generation of positive charge in the cathode. So in the anode we have negative charge, in the cathode we have positive charge. So we have more electron in the anode, and we have very less and very deficiency of electron in the cathode. So due to the difference of electron number, because we know that the higher concentration will move to the lower concentration, high voltage will move to the lower voltage, and high height to the low height. So this means that high most electron will move to the low molar electron. This means that electron will flow from anode to cathode, because anode is negatively surplus electron. So due to the flow of electron, we have current, and current will flow in the opposite direction. We all know current flow in the opposite of the flow of electron. So we will have a current in the wire, and when we are connecting this wire with a bulb, then this bulb will glow because we have the current in the wire. Now what is the use of the salt bridge? The salt bridge will help in the, completing the circuit, because when we don't have the salt bridge, then definitely these two beakers will not be connected, and this means they will have a breakage, the circuit will be broken out. So to join this to complete this circuit, what will have we have the salt bridge. So this is the basic, working of the galvanic cell. Now coming to the how potential difference is generated. Now what is the electrode potential? So first of all, we will have the cell notation. Let's see how it is done. Now coming to the cell notation. So cell notation. So how we can? It is very difficult to represent the galvanic cell every time in the copy. So we have to represent the cell in a very simplest way. And how it can be done? First of all, we have to put anode reaction in the left side. Then we have the salt bridge. Then the cathode reaction. This means whatever happening in the anode, means in anode we have oxidation. So this means zinc is converting to zinc plus 2. So we have to write the reaction, that is zinc to zinc plus 2, and then we have this double line, means double parallel lines, means it is a salt bridge. Now the cathode reaction, copper plus 2 is going to copper. So first of all, write the anode should be in the left side, cathode should be in the right side. In between we have the salt bridge, and just write down the physical state and the concentration present. Suppose we have write down the zinc will be present in the solid state, copper is in the solid state, and zinc is in aqueous. Zinc plus 2 in aqueous, copper plus 2 in aqueous. And write down the concentration also. Suppose the concentration is, suppose this is C1 and C2. So write down the C1 molar and C2 molar. So this is how we represent a cell. And just remember, from left side and right side, always write the charges. So this is the representation of the cell. Okay, now coming to the cell reaction. We have the cell. We have the cell reaction. So how to write the cell reaction? So first of all, write the reaction happening in the anode. We have reaction in the anode as zinc was converting to zinc plus 2 with the 2 electron. Now in the cathode we have the reduction of copper plus 2 to copper. So write down the physical states. This is the aqueous, this is the aqueous, and just add the reaction to have the cell reaction. So what will have, and the two electrons in the left and right will be cut it down. Now Zn 2 copper plus 2 aqueous will be giving you Zn plus 2 aqueous to copper solid. So this is the cell reaction. So this is the overall cell reaction because we are adding the two half cell to have the cell reaction. Okay. Okay. Now coming to the cell potential. So what is the, first of all, just have the electrode potential. Electrode potential. So what is happening in electrode potential? So we have the oxidation first half, oxidation half reaction where we have the anode, and we know that the anode is negatively charged due to the oxidation, and because the Zn in the given example, Zn plus 2 was coming out of the rod in the solution. So we have what, positive, just surrounding the negative electron because opposite charges attract each other. So we have what we have a difference in the charges. Whenever we have difference in opposite charges, then there will be always a potential difference here. So this here we have a potential difference. So this is a potential difference occurring between the rod and the liquid solution. So this is known as electrode potential, and this will be called as oxidation. This will be called as oxidation, electrode potential. This means the after the oxidation, the potential difference generated between the rod and the liquid solution. So this is known as electrode potential. Now coming to the next potential. In the cathode again we have positive charge in the rod and negative charge will be surrounding the positive electrode because the cathode was positively charged and the solution will be the negatively charged because the opposite charge will attract each other. So again there is a potential difference between these two. We have a potential difference between these two, and this potential difference is known as reduction electrode potential. So we have two potential. This is called as reduction electrode potential. And when these two when are joined, then current will start to flow, and this is called as cell potential. So what is the cell potential? So cell potential means it is the potential difference between the anode and the cathode. Simply, here we have the individual potentials. In the rod, we have the oxidation potential. In the cathode, we have reduction electrode potential. So this will be written as E Zn 2 Zn plus 2, and this will be written as E copper plus 2 to copper because we have reduction here. So copper plus 2 is converting into copper. So E is for electrode potential. Here also this is anode. So we have oxidation here. So zinc is converting into zinc plus 2. So we have separate potential. And now when we are talking about the cell potential, means the potential of the cell, then we have to just add this E oxidation which is in the anode plus E reduction which is in the cathode. This simple formula where, and if you are converting E reduction in the cathode, then if you want to have the E reduction only, then use this formula, means E oxidation will be equal to negative of E reduction. So we use this formula generally because all the questions, in the questions we have E reduction only. So whenever you have the E oxidation, convert this into E reduction, and simple by putting minus sign. So this is called as cell potential. So let us have a general simple question about this cell potential. Suppose suppose question is, if we have E Zn plus 2 to Zn is given minus 0.73 volt, and E copper plus 2 to copper is given plus 0.34 volt. Suppose this is given. Now, so we have to find E cell. Actually, here we have standard value also, because standard, this is called standard electrode potential. And what is this standard electrode potential? Is that electrode potential where the concentration is 1 molar and the pressure is 1 bar at a specific temperature. So the concentration is fixed to 1 molar and the pressure is fixed to 1 bar, and that in that case the potential will be known as standard potential. Electrode potential will be known as standard electrode potential. So the knot indicate the standard one. So we can also have the standard cell. Again, the same condition is given. So how we can do this? Suppose this, how we can find whether which one is anode, which one is cathode. So see here, this is a copper plus 2 to copper. So the positive value indicate that the copper plus 2 wants to be the copper. So here it will be the cathode, and this will become the anode. Now the again in the formula we have E naught reduction of cathode minus E naught reduction of anode. Just put the value 0.34 minus of minus 0.76, and this is nothing but 1.1 volt. This will be plus sign. The plus indicate the reaction is feasible. So this is how we can find the cell potential. Okay, thanks.